Now that you know the basics of creating figures and creating subplots or axes inside figures, it's time to move forward a bit with learning how to plot data inside those axes. We are going to start in this video with plotting lines in 2 dimensions and also lines in 3 dimensions. Now you've already seen the plot function several times before in this course, so it's not totally new, but I'm going to show you how to use the plot function a little bit more rigorously. I think by the end of this video you will be pretty comfortable using the plot function and plot3 to draw multiple lines on top of each other using the hold function, and I'll also show you how to make the plots look a little bit nicer using additional inputs into the plot function. So let's begin. So the basic way that the plot function works is that you provide 1 or 2 inputs. So if you provide 2 inputs, then that's going to be the x-axis coordinates by the y-axis coordinates. So here I'm going to plot 1 through 10 on the x-axis, and the y-axis is going to be 1 through 10 squared. So essentially I'm just plotting x by x squared. So let's see what this looks like. So here you see the line going up, and you can see the last one is 10, and that corresponds to 100 on the y-axis. Now, in this particular case, you don't actually need to provide the first input. If you provide only one input into the plot function, then by default, Matlab will choose the x-axis to be integers going from 1, starting at 1, going through the number of elements in y. So it just happens to be, in this case, that you get exactly the same result. Okay, so let me undo this. Now we get x by y. And now I'm going to run another plot function. It looks really similar, except here it's x squared, and here it is the log of x. And what I would like you to notice is that this plot here of x squared now disappears, and it gets completely replaced by this plot of log x. So when you run the plot command again, it's going to delete all of the previous lines and images and whatever else was in that axis. Okay, but if you want to plot multiple lines on top of each other, that's possible. You can do that using a function called hold, and in particular we want to type hold on. So hold means that Matlab is going to hold the graphics on the current axis. So now I run hold on, and then I plot this line, or I run this line, and now you can see both plots, or both lines, are on simultaneously in the same plot. So this is log x, and this is x to the power of 1.5, or 3 halves. You can also notice that by default, Matlab changed the color. So this was the first line, it plotted it blue, and the second line plotted in red. Now that's not something that I explicitly told Matlab to do. Matlab just, figured out that, or guessed that it's useful to have different colors of lines to make them more easily distinguishable. In a few moments, I'm going to show you how to set the color yourself. Okay, now I'm going to type hold off. So notice when I typed hold on, then Matlab drew this line on top of the axis. Now I'm going to type hold off. And the question is, what happens when I run this line of code? Is it going to still plot on top of these graphics, or will hold off mean that this new plot will override these plots? So it turns out that it's the latter. We lose the previous graphics. So that's the importance of hold on and hold off. Okay, so now I want to show you a little bit about customization of lines. I'm going to type CLF to clear the figure. Now I'm going to type plot. So this is actually the same that we've done so far, except now I'm adding 2 additional inputs. These additional inputs come in pairs, so you can see there's 2 of them. There's a pair, and these are called property value pairs. So this is the property, and this is the value. The property is line width, obviously that's the width of the line, and 3 indicates the value. Now this doesn't mean 3 pixels or 3 inches or 3 meters. It's just kind of an arbitrary number. So you'll often have to play around with these, with this value to see what looks good on your particular screen with your particular data and so on. The default, I believe the default is 1, and this can get pretty large. It can be like comically large. So this is probably a little too thick of a line to be useful, but just to give you the idea. Okay, so let's see, let's get back to this one. So this, you can see, is thicker than the previous lines that we were plotting. Now I'm going to type hold on, and now here is also more than one input. So this is the X values, the Y values, and this looks like a funny input. It says R minus D. In fact, this stands for red. The R is for red, the dash is for a dashed line, and the D is for diamonds. So let's see what this looks like, and then we'll see if we can figure out how to decode this. So if you look at this line, and if you're watching this video on a small screen, then you might need to inspect this closer on your computer screen, in Matlab, that is, not on the video. So it's a red line, and it's dashed, so we have a solid line between the points, and then the marker, which is the data point at each point that's evaluated, is a diamond. So let me show you a few different options here, and let me just get rid of this comment here. So you can have, let's see, so for example, black is K. Now we get a black line. I can get rid of the dash there, that hyphen, and, well, okay, actually, so that didn't plot the lines, but you wouldn't know that because it was plotting on top of the previous plot, because hold on is, or hold is set to on. So I'm going to make this blue, and now you see, this is really hard to see. Okay, let me run this again. Let me just clear the figure. When you clear the figure, that also sets hold to be its default value, which is off. Okay, so now we get blue diamonds, now we have red diamonds, and now I can put a line between them like this. There's many options. You can have a colon here, and that's going to be a dotted line. You can have two hyphens, that's going to be a dashed line. So this is with diamonds. You can also have squares and pentagons, which is like a star, a five-pointed star. You can have the caret symbol, which gives you triangles. There's many options, and here in the comment you can see it says type help plot to learn more. So I'm going to type help plot, and you can see here all sorts of options for the line color and the marker style and the line style. So I just showed you a couple of these individuals, and then you can explore these further on your own. So there's many options for specifying the quality of the line. So the line itself that connects the points and the markers at each individual point. And now these are mixable, of course. So I can type red dashed line with diamonds, and then I'm going to say line width and 10. So I'll make this a really thick line here. Okay, it's too thick. I guess you don't really see the diamonds, but I think you get the idea. Okay, so this is for plotting. What I want to show you now is plotting a straight line. Drawing a line is simple, but it can be a little bit confusing at first. So if you want to draw a line, what you do is specify the start and end points on the x-axis and the start and end points on the y-axis. So before even running this line of code, let's think about what it's going to do. So we are going to draw a line that goes on the x-axis from 2 to 9, and on the y-axis it's going to go 60 to 60. So in fact, this is not going anywhere on the y-axis. This is going to be a flat line. It's a horizontal line that goes from 2 to 9, and I'm going to draw that on top of this one, and let me get rid of this. I'll set this line width back to 1, so it's slightly less comical. Okay, so now we get this, and now I'm going to plot. This turns out to be a black horizontal line. It goes from x equals 2 to x equals 9, and y equals 60 to y equals 60, which means it's a flat line across the y-axis. So that's that one. And then here is going to be a diagonal line that will go from 1 to 10 on the x-axis and 0 to 100 on the y-axis. And that's going to be a magenta, that's what M is for, magenta dotted line. I hope you can see this on your screen. It's a little bit faint. So in theory, we could make the markers larger to make this line more prominent, but I'm not going to discuss that right now. Okay, so now we release the hold. And by the way, you can also just type hold without typing on or off, and that's just going to toggle back and forth. So you can see now it says current plot released, now it says current plot held. I actually don't recommend just typing hold on its own, because then you have to keep track of whether hold was already on or hold was already off. So it's always best practice to explicitly write hold on or hold off. Now, there's nothing new in these 4 lines of code. I just want to show you that rather than inputting the numbers directly into the inputs in the plot function, you can also set them to be variables. So now I'm plotting x comma y, where x and y are variables that I have already defined. And what I'm showing you here is that x and y need to be of equal length. So here I set x to be numbers going from 0 to 1 in steps of 0.1. But then y, so x is 11 points long. But now y is actually 12 points long, and that's because I'm concatenating 0. See, I have these square brackets here. So I'm concatenating 0 with e to the x. And so then we get an error message. And the error message is vectors must be the same length. So whenever you are plotting or visualizing data, if you see an error message that's related to dimensionality or length, you know that the first thing you should check when you see an error message like this, the first thing you should check is the sizes of the input vectors or matrices, and it's pretty likely that one of them is going to be a different size from the other. Okay, so I've already shown you a function CLF to clear the figure that completely wipes the figure clean. This is the function CLA, and that stands for clear axis, and that is not going to get rid of the axis, it's only going to get rid of the information contained inside the axis. So when I run this code, the axis is still here, but it just gets reset, and everything that's on the axis gets wiped off, including if you have hold on. All right, so then, let's just plot some other things here. Here I'm plotting 3 lines. This is 3 lines because this matrix is a 10 by 3 matrix. Now, Matlab is always going to plot column-wise, so there's 3 columns, so that's why we get 3 lines. If you wanted this rotated the other way, let's say you want 10 lines of 3, then you could change this. So now we have 3 rows and 10 columns, and we're going to get a very different plot here. Notice also the x-axis now goes 100 up to 1000 in steps of 100. Oh, okay, so I actually realize now what I just said isn't totally true. So Matlab is actually going to analyze the size of this matrix, which actually is 3 rows and 10 columns, and compare that to the size of the x input, or the first input, and that's 10. So Matlab is recognizing that the only way to get these to work, these to be consistent, is if this ends up being plotted as 3 lines of 10 points each. But if I were to delete that first input, so then Matlab can select the x values by default, now we get 10 lines that are 3 points each. So you see this just goes 1, 2, 3, and there's 10 points. And if I were to say 10 comma 3, then it's still going to be drawn column-wise, so we have 3 columns, and we get 3 lines here of 10 points each. All right, so that's a pretty decent introduction to the plot function, I hope. What I'm going to show you now is a few ways to make the axis look a little bit nicer. So I'm going to use a function called title, and then the input to the title is text, and that gets drawn up here. That gets written out up here. And then we have something called x label, and that labels the x-axis, and y label is the same concept. The main point that I'm showing here is that you can use this special escape character, so this backslash, and then I'm writing out mu, mu. And Matlab knows to interpret this as the Greek character mu. So you can see here on the y-axis this says voltage, and then this is mu v. It's not u, this is the Greek character mu v, so this is for microvolts. This would be if your data are in microvolts. And there's other ones, you can do alpha. So now we're going to get alpha v, whatever alpha would be for in this case. And in general, it's possible to use LaTeX coding in your axis labeling. Okay, and then we have a legend, and a legend is going to provide labels, information for the 3 lines. So we have the blue line is called line 1, the red line is called line 2, and the yellow line is called line 3. So you can see that I'm inputting a cell array with 1 element in the cell for each line that is being drawn. And Matlab is going to associate these in order. So this was the first line, so it's called line 1, so the first element here, the second line, and the third line. Now you can also just click and drag this thing. So I left click on this little legend box and I'm dragging this around, I'm moving this around. There are also other ways that you can specify the location of this legend, but by default Matlab is going to put it somewhere in the top right. Alright, so that's all about the plot function to generate lines in 2D. I would like now to take a moment to introduce you to plotting lines in 3D. The good news is that it's essentially the same process. It's not really different from plotting in 2D that I already showed you. We just have to use a different function, so we use plot3, and then we are going to be inputting 3 values. So we need to input 3 things here. It's the x coordinates, the y coordinates, and the z coordinates. So this is nothing particularly interesting. I'm just generating a bunch of random numbers. And then these are going to get plotted in a separate figure, figure 2. Now it's kind of hard to see what's really going on here, although it's kind of interesting that it randomly ended up being almost a perfect pentagon here. Okay, so now I'm going to turn the grid on. So let's see what this function does. So I run this line grid on, and that draws these grid lines, these gray grid lines on the back, and that just allows you to see the plot a little bit nicer. We can also put that on here. I can say grid on, and that shows these grid lines here. All right, and then there's another function called rotate 3D on, and that's going to allow us to click and drag and rotate this graph around here. You can activate rotate 3D on by running this line of code, but you can also activate it directly from here. So if you see, as I put the mouse over the axis, I get a couple of little icons up here. So there's a zoom icon, zoom in, zoom out, a pan icon, and I want this, it's hard to see exactly what this is, but it's a drawing of a cube with an arrow going around it. So I can click that, and that is going to activate 3D, rotate 3D. Then now what I'm going to do is left click on the figure and move the mouse around, and that's going to rotate this figure around in 3D, and that allows us to explore these data from different angles, different viewpoints. By the way, you can also access these. So this was fairly recently added. I think it was in Matlab 2018. But if you're using a slightly older version of Matlab, you won't have these options up here. So you can also click on the figure menu bar. And if you have an older version of Matlab where these options are not appearing automatically up here, they are instead going to appear over here. So they look the same. It's still going to be a cube with a little circle line drawn around it. Or you can just type rotate 3D on here. Okay, and then other features work basically the same as what I already showed you. So we can add axis labels, x-axis, y-axis, z-axis. And let's see what happens if we run this line. So you might think that we have these 3D data. So you might think that it should be pretty straightforward to plot these as 3D lines because they are already in 3 dimensions, right? So there's 3 rows here. However, it's unfortunately not quite so simple. So if we try to plot plot 3, Matlab will say not enough input arguments. So in fact, the way we need to do this is still tell Matlab explicitly to draw these 3 lines. So these are the x coordinates, the y coordinates, and the z coordinates. And I'm also showing you in this line that you can add these options that I had illustrated earlier. And I'm also adding a few new ones like the marker face color and the marker size. So that's the size of the marker at each individual point. So let's see what this looks like now. All right, so here we get our, I don't know what this is. This looks like Christmas lights that are all tangled up. Okay, and then a few other options. There's many plot options, ways to update the graphics and change the look and the feel of the graphics. So I'm just going to be like slowly introducing these to you throughout the next several videos. So we can switch the axis off. So you can see the axis here. I can run axis off. Now that doesn't get rid of the data, but it does make the axis behind the data invisible. Okay, and then there's one final thing I want to show you in this video. I'm going to turn the axis back on. Notice what happens when I rotate this around. You can see that the size of the axes, it's most noticeable with the z-axis. The size of the axes, the scaling of the axes is changing as I move this around. And Matlab is doing that intentionally. Matlab is trying to figure out what is the best way to fit all the data in given the view that I am rotating into. But you can force the axes to be the same by typing axis square. So now all the axes have the same length, and as I rotate them around, the axes are not actually changing in size. So there's other options too. You can try typing axis tight and axis normal, that's the default, just to give you a bit of a sense of what these different options are like. So I hope you found this a useful introduction into plotting lines in 2 dimensions and in 3 dimensions. I hope you also see that the basic functionality for plotting is really simple, it's really straightforward. And on the other hand, there are many options for adding aesthetics to make your lines look even nicer. And I'll get into more of these kinds of details about changing the plots in a later video.